So what we're going to do is learn how to complete the square, which is a method in which we rearrange a quadratic so that we have it in this form. And if you've watched the video on the completed square form of a quadratic, this is a useful way to express the equation as it allows us to very quickly read off the turning point. Okay? So we've dealt with them in the past where we've been given them in completed square form, or we've just fully put them into completed square form from the graph. What I'm now going to do is, from the expanded quadratic, put them into the completed square form. There's two methods of doing this. I'm going to show you both. This is one video showing you one, and then you can watch the other video, and then you can decide which one you prefer. I don't mind as long as it's a correct method. And so we can then state the coordinates of the turning point. Okay, so this method is just simply rearranging it from here. The way we do this is we firstly make sure if we need to do anything with the x squareds, you can only really do this method if the x squared has a coefficient of 1. And as you can see, this does have a coefficient of 1. You can see in the extension that we deal with something there, but we'll come to that in a minute. So you get the bracket, x plus, and now you half the middle term. So what's half of 6? It's 3. And you square it. So they've got that part sorted. And now we need to sort that. That plus 9 is still there. But if I was to expand this quadratic, I would get x squared plus 3x plus 3x plus 9. And so I need to fix that by then what we do is we take this term that we've added in and we subtract it squared. Okay? And then we simplify. 3 squared is 9. And so x plus 3 squared equals 9 take away 9 equals 0. Which we would just write really as x plus 3 squared. Which means our turning point is going to be, change the sign of the x, and if it's 0, we'll just put in 0. Okay? So, let's do it for another one. Half this middle term. And then subtract whatever this is squared. This is where people can get it a little bit wrong. Negative 5 squared is positive 25. But there's a negative outside the brackets, so we're still subtracting. 2 minus 25 is negative 23. Okay. So, what is the turning point? Change the sign of the x and keep the y the same. Right. If we had to do one like this, which is a bit more complicated, I told you that we can't really do this method unless the x squared has a coefficient of 1. Which right now it doesn't. So what we're going to do is give it a coefficient of 1 by taking out a common factor. I'm going to do big square brackets, because I know that I'm going to have 2 sets of brackets. If I take out a common factor of this 3x squared plus 12x, I'm going to be left with x squared plus 4x. Okay? Just treat these as brackets for now. It's just to distinguish them from the next pair of brackets that we're going to create. And now what we're going to do is complete the square of that and ignore everything else, but remembering ultimately that there is still brackets here. So if I was to complete the square of this expression, and then we'll deal with the rest of it, that's going to become x half of the 4x becomes 2 squared. There's no number here to worry about. So we then subtract whatever this term is squared. Remember, it is within a bracket. So that stays the same. 2 squared is 4. I don't want this bracket here, so then we multiply it out by the 3. Three times everything in here, so it becomes 3 bracket x plus 2 all squared. 3 times negative 4 plus 1, because that's 3 is not multiplying that 1. Negative 12 plus 1 is negative 11. Okay, now I can read off that that turning point is negative 2, negative 11. Okay, so these are fairly okay. This one's a bit more complicated, but this is just one of the methods of doing it. Okay, and another video is the second method of doing it, the other method of doing it.